Hey guys, Lin here. A couple of days ago, I published a video on how network cache-based identity could potentially be mistaken. In that example, I showed when Cilium pod couldn't communicate with the Kubernetes API server. Today, we're going to go through the same scenario with the Istio control plane. Are you ready for this? Let's get started. This is my Kubernetes kind cluster. I have 3 worker VM. My application have Sleep version 1 and version 2 and Hello World version 1 and version 2. Where Sleep is the client and Hello World is the server. I also have Cilium installed as my CNI. I have Istio control plane deployed with the minimum profile. I have enabled sidecar injection in the default namespace where my client and server application runs, which is why you see 2/2 with the sidecars. I have Cilium network policy deployed where version 1 only allows Sleep version 1 to talk to Hello version 1, and version 2 only allows Sleep version 2 to talk to Hello version 2. I also have a couple of authorization policies. So the first policies are now nothing in the default namespace, and the Hello version 1 allows the Sleep version 1 to call Hello World version 1. And Hello version 2 allows Sleep version 2 to call Hello version 2. Going back to the terminal, I'm going to check how Sleep calls Hello World. As you can see, version 1 to version 1 is success. Version 2 to version 2 is success. Version 1 to version 2 was version 2 to version 1 is connection fail. This is because Cilium network policy recognize they are not allowed. So this works perfect in the perfect world. Since we don't live in a perfect world, now I'm going to trigger an error scenario where the node hello version 1 runs couldn't communicate to the API server. Let's review our test script. We're going to capture the Sleep version 1's IP address, and then we're going to scale Sleep version 1 to 0 and the Sleep version 2 to 15. And then we're going to try to find that particular Sleep version 2 pod that has the same IP as one of the Sleep version 1 pod. And then we're going to curve from that Sleep version 2 pod to Hello version 1. Let's go ahead and run the test. Bring up our K8s window, and now we're seeing a bunch of Sleep version 2 pop up, and Sleep version 1 is scaled down to 0, just as we asked the system to do. Now we're rolling restart the Sleep version 2 pod to hoping to get a match of the winner soon that meets the condition of reusing one of the Sleep version 1's pod IP. Checking onto one of the Sleep version 2 pod, we can see the pod is taking up longer than usual to come up. This is because one of the Istiod couldn't serve as the certificate authority to create, to fulfill the certificate signing request. Oh, it did come up. So Envoy is ready now, and looks like everything is up. Let's go back. Oh, we have a winner too. So as you can see, we were able to find the Sleep version 2, and this time we call Hello version 1, and we got ABAC, access denied. That's an error message from Istio. So this really shows how Istio authorization policy is enforced so that Sleep version 2 couldn't talk to Hello version 1. All right, let's recap what you have seen. On the VM where Hello version 1 pod runs, we introduced an error scenario where it could not talk to the Kubernetes API server. There's one Cilium pod running on that VM. There's also one Istiod pod running on that VM. Cilium network policy layer 4 could not be enforced because the identity of our sleep version 2 pod was mistaken, so it allowed the access. But because we have Istio authorization policy in place, the Istio authorization policy was enforced. So at the end, sleep version 2 could not talk to Hello version 1. This really shows how important it is to have a defense in-depth strategy in your organization. If you enjoyed this video, please give me a thumbs up and subscribe to our channel so you don't miss any of our future educations on Istio, Envoy, Cilium, eBPF. Thank you so much for watching.